Homework busy? No more. At Spring Library, we explain every topic in simple way. Join the learning family and score high every day.
An oil drop with some unknown number of excess electrons is held at rest between two very large plates with a separation of 1 centimeter. We're told that the oil drop stays at rest, and we want to know how many excess electrons does the oil drop have. So if we look at our oil drop, the forces will be mg, the weight, and then the force due to the electric field, which will be E times Q, where Q is the charge of one electron times the total number of electrons in. So we need to first find the electric field. Well, the electric field is going to be equal to V over D, where D is equal to the separation between the two plates. So in this case, the V is equal to 340. So it's equal to 340 volts over 0.01 meters. So this will give us a total of 34,000 newtons per coulomb. So we can now solve for N. So if we equate our forces, we get that E times Qn is equal to mg, which tells us that N is equal to mg over EQ. So we can now plug in. The mass of the oil drop is 2.8 times 10 to the 5th, so E equals 2.8 times 10 to the minus 15th, kilograms. The gravity is 9.8 meters per second squared. E is 34,000 newtons per coulomb times the charge of an electron is 1.6 times 10 to the minus 19 coulombs. So if we plug all of this in, we get 2.8 times 10 to the minus 15 times 9.8 over 34,000 times 1.6 times 10 to the minus 19. And this gives us that the number of free electrons, N, is equal to 5.